Hey guys, in this video I'm going to show you how to answer the Maths Method Sample Exam 2 Extended Response Question 4 Parts B and C. This question is testing your understanding on log functions. And so reading the question, we've got the mining engineer Victoria decides that a better site for the mine is the region bounded by the graph of G and that of a new function k, where k of x equals minus log e a minus x, where a is a positive real number. Find in terms of a the x coordinates of the points of intersection of the graphs of G and k. To find the points of intersection, we need to let g of x equal k of x and then solve for x. And so doing this, we're going to get log e of x is going to equal minus log e of a minus x. Bring the right hand side to the left hand side, we're going to get log e of x plus log e of a minus x is equal to 0. Applying the log laws, this is equivalent to log e of x times a minus x, and this is going to equal 0. From here, e to the power of 0 is going to equal x times a minus x, which is ax minus x squared. E to the power of 0 is equal to 1, and so this is going to be 1 is equal to ax minus x squared. Rearranging this, we're going to get x squared minus ax plus 1 is equal to 0. We now have a quadratic equation, and we can use a calculator to solve for x in terms of a. And now solving for x, we're going to get two solutions. And so for the first one, if we multiply the negative inside the brackets, the points of intersection is going to be in terms of a plus or minus the square root of a squared minus 4 divided by 2. Part 2. Hence find the set of values of a for which the graphs of g and k have two distinct points of intersection. We just worked out the x coordinates of the points of intersection, and this was x is equal to a plus or minus the square root of a squared minus 4 over 2. And we got this by solving a quadratic equation. Now for the graphs of g and k to have two distinct solutions means that the discriminant, which is the term underneath the square root sign, must be larger than 0. And so therefore, to have two distinct points of intersection, a squared minus 4 has to be larger than 0. This is a quadratic inequality, and so sketching its graph, we're going to get a parabola that's shifted down 4 units with x-intercepts at minus 2 and at 2. And so looking at the graph, we can see that for values of a less than minus 2 and for values of a larger than 2, this inequality is going to be larger than 0. But we were told that a is larger than 0, and so therefore the values of a, where we're going to get two distinct points of intersection for the graphs of g and k, is going to be when a is larger than 2. Part C. For the new mine site, the graphs of G and K intersect at two distinct points A and B. It is proposed to start mining operations along the line segment AB, which joins the 2 points of intersection. Victoria decides that the graph of K will be such that the x-coordinate of the midpoint of AB is root 2. Find the value of A in this case. We have a line that connects the points A and B, and we're told that the midpoint of this line segment has an x-coordinate which is equal to root 2. We know that to find the midpoint of a line segment, we use the rule x1 plus x2 over 2 and y1 plus y2 over 2. If the x-coordinate of the midpoint is equal to root 2, then we can say that x1 plus x2 over 2 is going to equal root 2. x1 and x2 are the two x-coordinates where the graphs of g and k intersect. In other words, the x-coordinates of the points of A and B. And we worked out that these coordinates are going to be x is equal to a plus or minus the square root of a squared minus 4 over 2. And so we can say that x1 is going to be a plus the square root of a squared minus 4 over 2, and x2 is going to be the point a minus the square root of a squared minus 4 over 2. And so from here, if we sub this into the equation we just got, we're going to get x1 plus x2, which is equal to a, And so this is going to become a on 2 is equal to root 2. And so solving for a, we're going to get the value of a is equal to 2 root 2. And that's it for this question. Now, if you guys want to learn or revise exam-style questions related to log functions, then you can easily do this by logging into the Maths Methods Club. All you need to do is click on Functions and Graphs from the main topics. And then from the subtopics, select Logs and Exponentials. And for extended response questions, go to Question Type and select Extended Response. Here, you're going to see all the past exam questions in relation to log functions found in the Extended Response section. Go through these questions so you can better prepare for your SACS and exams. And if you get stuck, you can just watch the solutions. Thanks for watching, good luck, and I'll see you guys in the next video.